In this section, we look very briefly at functions, so just a quick introduction. So these are a very useful way to write these expressions and formulas we've been looking at, this special function notation. So here's an expression we looked at last time, 16t squared. And this is a formula for the distance in feet an object falls in t seconds. To make this a function, we can give it a name, like f or g or any letter, and we write this. So this is setting up our function. The way to read this left side is f of t, and that's equal to 16t squared, that expression. All right, so this sets up the function f. So now, so this f, it's a function of t, so the variable is t. And if you give the function a number, it gives you back this number. And so f of 3 means substitute 3 for t. Okay, so putting in 3 on both sides. So f of 3, well, here we're getting 16 times 3 squared. 3 squared is 9, and 9 times 16 is 144, yes. So f of 3 is equal to 144. Okay, but you could put in different numbers into the function. If you put in 0, so when t is 0, well, what is f of 0? We'll replace t by 0. We're getting 16 times 0 squared. That's just 0. If you put in 1, so f of 1, that's 16 times 1 squared. That's 16. And f of 2, put in 2 for t. That's 16 times 2 squared. So that's 16 times 4, 64. All right, so it's, nothing new except this, just calling everything, calling this expression a function now. So here we have the function notation. So again, this means f of 2 equals 64. And you can think of that number 2, that's the input. That's the number going in. Okay, so you give the function the number 2, then the function works its magic, and then 64 comes out. So 64 is the output, and the number coming out. Yeah, so you can think of a function. So this one, it starts with 2, and then it does something, and 64 comes out. So this is the 2 is the input, and 64 is the output. Okay, so that's a good way to think of these functions. So a number going in and a number coming out. For a function like this f, Yeah, it's important to remember that f of t does not mean multiplication, and f is not a number. So that's one problem with this notation. It looks like you're multiplying a number f by a number t, but no, we have this special function notation, so we're not multiplying here. It's instead of multiplying, we have to use the function's formula. Okay, here's a different function. Let's call it g. Let g be the function given by this formula. So g of x, instead of this here the variable was t, but it could be any letter. G of x is equal to x squared plus 4x. All right, so this function has a different recipe. There's a different formula controlling it. So whatever number x you give this function, it gives you back x squared plus 4x, whatever that number is. Part A, find g of 0. And yeah, it's good to say it correctly. So it's g of 0 for functions. And all this means, again, is that we're replacing x by 0 on both sides. And so on the right side, we're getting 0 squared plus 4 times 0. That's just 0 plus 0, 0. So the number coming back out is 0. So g of 0 equals 0. So 0 went in and a 0 came out. Part B, let's say the input is 5 this time, so we want g of 5. So now 5 is going in. So instead of, so that all the x's get replaced by 5's. So we need 5 squared plus 4 times 5. Exponents first, that's 25. Multiplication next. Addition last, 45. All right, so for this function g, when the input is 5, the output is 45. 45 comes out. All right, so yeah, you see that we're not really doing anything new. We're just evaluating this expression, this formula, for different values of x. The last one, g of negative 2. And now negative 2 goes in. So substitute negative 2 for x. Use parentheses. So we have negative 2 squared plus 4 times negative 2. Negative 2 times negative 2 is 4. Then do this multiplication, negative 8. So we have 4 plus negative 8. Adding two sign numbers with different signs. Subtract the magnitudes. 8 minus 4 is 4. Use the sign of the bigger number. So we need a negative 4. And that's the output. So negative 4 came out. G of negative 2 is equal to negative 4. Okay. So here are functions in the book. Yeah, one of the simplest types of functions is called a linear function. So it takes x and just multiplies x by a number and adds another number. So simple functions like that are called linear functions. So for this example, f of x is equal to negative 2x plus 300. Find these different values of f. All right, so what's happening with this first one, f of 0? So we have to replace x by 0. So it's negative 2 times 0 plus 300. And negative 2 times 0 is 0, so we're just left with 300. So f of 0 is equal to 300. F of 10. And now replace x by 10, so we're getting negative 2 times 10 plus 300. Negative 20 plus 300 is 280. F of 25, we're getting negative 50 plus 300. That's 250. So for this f, when the input is 25, the output is 250. And if the input is 150, 150 goes in. Negative 2 times 150 is negative 300. Plus 300 cancels, so we get 0. So when 150 goes in, 0 comes out. Okay, of course, you could have decimals or fractions. So for this, yeah, we talked about linear functions. So a quadratic formula, a quadratic function has an x squared. Slightly more complicated. This function h of t, it's equal to negative 16t squared plus 100. So this is an example of a quadratic function. And this one's telling you something, like the example we saw earlier. If you drop something from a 100-foot tower, then after t seconds, the object is at height h of t. So this function, h, is giving you the height in feet of an object that you drop from a tower. Yeah, here h stands for height. Okay, so using this formula, using this function, find the height of an object 1.5 seconds after it is dropped from this 100-foot tower. Okay, so we're just going to use this function. It's telling us the answer. We just have to replace t by 1.5 or 3 over 2. Okay, so we need h of 3 over 2. So we're substituting 3 over 2. So it's negative 16 times 3 over 2 squared plus 100. We have to do the squaring first in the order of operations. 3 over 2 squared, that's 9 over 4. Multiply that by negative 16. That's, well, 4's cancel. So it's really negative 4 times 9. That's negative 36. Add on the 100, 64. All right, so after 1.5 seconds, the object you dropped from 100 feet at the top of the tower, it's 64 feet above the ground. That's its height. Yeah, so you can see other values of t. So when t is 0, then the height of the object is 100. So it's at the top of the tower. When t is 1, so after 1 second, you're getting negative 16 plus 100. That's 84 feet high. 1.5 seconds, it's 64 feet. Okay, so eventually it'll hit the ground. All right, so these are all examples of functions. And yeah, saying here, yeah, all we're doing is we're just evaluating expressions or formulas as we've been doing. So it's just another example of that. Yeah, Math 30, pre-calculus. So if you're on a science track, pre-calculus is, yeah, it's a detailed study of just functions, all types of functions. All right, so let's go back to this section. So in section 1.9, there's the Pythagorean theorem. We just had a quick look at it when we were in chapter 1, so now we'll go back, look at it in more depth. It's yeah, a very nice example of expressions or formulas coming from this theorem. Okay, so what is the Pythagorean theorem? I'm sure you've heard it before. So here it is in the box. So the Pythagorean theorem says in a right angle triangle or a right triangle, the sum of the squares of the two short sides equals the square of the long side. So here's a right triangle. So here's the 90-degree angle. So on each side of the 90-degree angle, you have the two legs, the two short sides. And the sum of the squares of those two short sides, those two legs, is equal to the square of the long side. That's the hypotenuse. All right, so that's what this theorem says. Yeah, so I mean, it's just relating the three sides of a right angle triangle. Yeah, it's not a simple relationship, so it's not just a plus b equals c. It's you have to square everything. So a squared plus b squared equals c squared, the square of the hypotenuse. Okay, yeah, again, the shorter sides, those are the legs. They're on each side of the 90-degree angle. The longest side is opposite the 90-degree angle. That's the hypotenuse. Example 1, if the legs of a right-angled triangle are length 3 and 4, find the length of the hypotenuse. All right, so our picture could look like this. So using our letters, so A is 4 and B is 3, or A is 3 and B is 4, it doesn't matter, but A and B are 3 and 4, and we're looking for C. And so substitute, so 4 squared plus 3 squared is equal to C squared by the theorem. And that's 16 plus 9, that's 25. So 25 is equal to C squared. And so C is 25. Note, C squared is 25. So we're looking for a number so that when you square it, you get 25. Well, C has to be 5. Yeah, C is a length, C is a positive number. The only positive number that squares to 25 is 5. So that's the answer. The hypotenuse we're looking for had length 5. And that certainly looks reasonable from the picture. So just a bit bigger than 4. Yeah, you certainly see 7. It's not the right answer. So 4 plus 3 is 7, but that's not what we're looking for. And yeah, this last step here, so 25 is equal to C squared. Well, so what number squared is 25? Well, that's really the definition of a square root. So to solve something like this, you can think of it as just taking the square root of both sides. Okay, so square roots and squares are opposite or inverse operations. So the square root of C squared is just C. And the square root of 25 is 5. All right, so we need square roots for this last step. Okay, so if A squared plus B squared is equal to C squared, then take the square root of both sides. C is equal to the square root of A squared plus B squared. So we're getting a nice expression, yeah, a nice formula for the hypotenuse. Okay, so put it in a box. So we'll use this formula. So if you know the lengths of the two legs in a right angle triangle, then to get the hypotenuse, you need the square root of the sum of the squares of those two legs. All right, so yeah, a simple formula to add to your list. Example 2, find the hypotenuse length if the legs are of length 5 and 12. Okay, so it's just a direct application of this formula, putting in 5 for A and 12 for B. the two legs, and we're looking for C, the hypotenuse. So substituting. All right, so we're getting the square root of 5 squared plus 12 squared. Yeah, I've noticed some of you in the homework are still confused between square roots and long division. So this is not a long division. So this is a square root symbol. Just for long division, we're just using this. And so this extra piece here means square root. So let me emphasize it. So this is the square root of this. So it's the square root of 25 plus 144. Okay, now this does not mean the square root of 25 plus the square root of 144. So this does not mean 5 plus 12. It's, you have to add these two numbers first. So it's the square root of 169. What number squared gives you 169? That's 13. So 13 times 13 is 169. All right, so the answer is not 17, it's 13. Okay, so when you're working out a square root of a bunch of stuff, then just work out what's inside the square root, what's inside the radical first. It's, this radical, it counts as a grouping symbol, so it's like there are parentheses here. Okay, so we found the C, so the hypotenuse has length 13. And so we're certainly expecting a number bigger than these two, so the hypotenuse is the longest side. So certainly 13 is bigger than both of these. Example 3, draw a right triangle with legs of length 6 and 7. The hypotenuse is slightly bigger than which whole number? Okay, so we can draw the triangle. Draw it this way around or the other way around, it doesn't matter. But the two sides on each side of the right angle have to be 6 and 7. Okay, so this is the picture, and we're looking for the hypotenuse C. Okay, I don't think this is a very accurate picture, but can you guess what this length is? Maybe 9, 10, something like that. All right, so let's see. So using our formula, hypotenuse, it's the square root of a squared plus b squared. So we need 6 squared plus 7 squared. That's 36 plus 49. Thirty-six plus 49 is 85. Yes. And then, we need the square root of 85. So so the answer is not a whole number. It's this doesn't work out evenly. The square root of 81 is 9. and the square root of 100 is 10. So we're between those two. So the square root of 85, it's somewhere between 9 and 10, closer to 9. Okay, so just between these two perfect squares, 81 and 100. So we can see, yeah, without using a calculator, you could check on your calculator, but the square root of 85, it's 9 plus a little bit more, so 9 point something. Yeah, so this length, it's just a bit bigger than 9. Okay, yeah, so if you're trying to estimate square roots, yeah, just see which, look for two even square roots that it's between. Okay, one more application of the Pythagorean theorem. And yeah, so this formula we've just been using, yeah, if you know the two legs, you can work out the hypotenuse. So we can rearrange that. If you know one leg and the hypotenuse, then you can work out the other leg. So it's our usual kind of situation. Yeah, there are three related numbers. If I give you two of them, then you can work out the third. Okay, so here's the Pythagorean theorem again. A squared plus b squared equals c squared. And we just want to rearrange this equation. So if this is true, then subtracting a squared from both sides, we get another true equation. B squared is equal to c squared minus a squared. And then take the square root of both sides. We're looking for b. We're isolating that other leg. Okay, so we get another formula. So b is equal to the square root of c squared minus a squared. Okay, so if you have a right angled triangle and you know one leg and you know the hypotenuse, then you can work out the other leg just using this formula. Yeah, it's very similar. We just have a minus sign. And the hypotenuse. Example 4, if the hypotenuse is 25 and one leg is 24, find the other leg. All right, so for this right triangle, we know the longest side is 25. One of the short sides is 24. What's the other short side? Okay, so this 25, that's the C. One leg, yeah, that's the leg we know, so that's the A. And we're looking for the other leg, that's the B. Okay, so C squared, that's 25 squared minus A squared, 24 squared. 25 squared, that's 625. 24 squared is 576. Subtract. All right, some big numbers. So inside we're getting 49. So it's a square root of 49. Which number squared gives you 49? That's 7. So b is 7, so that's the other leg we were looking for. So just spelling out our answer, so the other leg has length 7. And yeah, all we knew is that it's going to be something less than 25, so yeah, certainly 7 is smaller. All right, and any more in the book? I think there were some examples as well. Yeah, here at the end of section 6.2, again, the Pythagorean theorem. And then, yeah, taking square roots, you can solve for a, b, and c. So let's do this example. The hypotenuse of a right triangle is 169 feet, and one of its legs is 119 feet. How long is the other leg? All right, so we're using our the formula. I guess yeah, a and b are switched here, but it doesn't matter. We need the hypotenuse squared minus the leg we know squared, and take the square root to get the other leg. All right, so some big numbers: 169 squared minus 119 squared. Yeah, I think we need a calculator for this problem. So inside the square root, it's 14,400, and then the square root of that is 120. And so the other leg is 120 feet. Yeah, it's a length, and the units were feet. Yeah, I think we did this one already. All right, so the Pythagorean theorem gives us some nice formulas, nice expressions, and all we're doing for these types of problems is just substitute the numbers we're given. All right.